Hello, my name is Higashino from Z Engineering. For the past 42 years, we have been working with steam traps. During that time, we have seen steam systems in many different factories. This YouTube channel is not meant to defend or promote orifice traps. Instead, we will talk about the real problem that's actually occur in steam system in the field, and how we have tried to find answers to those problems through our work on site. That is what this channel is about.
Using an orifice trap to discharge large amounts of condensate. In reality, this does not work. Today, I will explain why. In the previous episode, we discussed the limitation of the orifice principle. When condensate flow fluctuates, a single orifice trap cannot operate properly. One solution to that limitation was the multi-stage design. Today, we will discuss another limitation. The amount of condensate an orifice can discharge is determined by two factors: orifice diameter and differential pressure. Intuitively, it seems simple. If the hole becomes larger, more condensate should flow. Anyone would think that. It sounds logical, but that assumption only applies to single-phase flow. Real steam systems are different. Designing a single orifice trap for very large condensate flow does not actually work. The founder of Z Engineering, my father, once said something interesting. If the hole becomes too large, vortices appear inside. At the time, it sounded like an intuitive observation, but in reality, he had identified the essence of the phenomenon. Inside the orifice, two completely different fluids are flowing together: steam and condensate. This is two-phase flow. When the hole is small, the flow remains relatively stable. But when the hole becomes larger, the internal flow becomes unstable. Rotating flow patterns appear. Vortices form. When vortices appear, the pressure balance collapses. The heavier water moves toward the outside. The lighter steam moves toward the center. At that moment, if the orifice is large, a pathway opens where steam escapes first. And when that happens, steam leakage begins. At that point, the device can no longer function as a trap. In other words, a single orifice design has a physical capacity limit. That is the reality. 42 years ago, my father recognized this limitation. Together with engineers from Mitsui Petrochemical, he conducted experiments with large condensate flows. For 3 years, they repeated tests. The idea that emerged was surprisingly simple. If one large hole does not work, what happens if many small orifices are placed in parallel? What if a single plate contains many small holes? This idea led to the creation of the Lotus-type multi-orifice steam trap. However, simply adding more holes is not enough. The number of holes, their arrangement, the balance of the flow. If these conditions are wrong, steam leakage appears again. After countless tests, the most stable structure was discovered. That structure is the current Lotus design. 42 years ago, Z Engineering obtained a patent for the Lotus design. Today, that patent has expired. In theory, any company can manufacture a multi-orifice trap. However, designing a system that can safely discharge large volumes of condensate cannot be done from drawings alone. You must actually run large steam flows, tens of tons of steam. You must repeatedly test hole diameter, hole arrangement, and internal structure. Very few companies have the facilities and the measurement data to do this. For 42 years, we have supplied thousands of Lotus traps to factories around the world, and we have confirmed their operation after 10 years. 20 years, even 30 years. They do not break. They do not leak steam. They continue to discharge, condensate. In the previous episode, we discussed the multi-stage design. Today, we discussed the multi-orifice design. Both designs were created by understanding the physical limits and learning from real field conditions. Engineering progress comes from that process. Understanding the limits, and then designing beyond them. That is what we learned from the field. In the next episode, we will discuss the TS1 trap designed for tire curing presses, another design born directly from field conditions.